Aloha. Thank you guys all for tuning in to our pre-recorded Zoom presentation. Today I'm featuring Dr. Bradley Romine, and he'll be talking about climate change and sea level rise challenges and responses in Hawaii. So without further ado, Brad.
All right, thanks Gavin. Thanks for the introduction, for having me today. Today I'm going to talk about climate change and sea level rise challenges and responses in Hawaii. As Gavin said, I'm Brad Romine with Hawaii Sea Grant. I also work with an organization called the Pacific Islands Climate Adaptation Science Center that we host here at the University of Hawaii, Manoa. It's nice to be talking to you online. Wish we could do this in person, but thank you for tuning in. I often describe my work as being kind of at the center point between science, planning, and policy. My education, my background, my past research is in coastal geology and coastal processes. But since then, still working here at the university, but working really closely with, particularly with local government, helping to kind of build two-way bridges between our university and our communities and our local government offices to try to bring that research from our university into the planning programs and the policy programs at government, helping to use that science towards better decision making, and then taking that the needs and better understanding the needs and what our communities and government needs are, and bringing that back into the university to help inform the research agenda, to bring the needed information to help improve our planning and decision making for our communities and improve resilience. So with that, I want to talk to you about, again, about sea level rise impacts mostly today. And the problems that we're experiencing along our coasts are because of nature, because we have high waves, very dynamic shorelines, hazard-prone shoreline environments. But it's also because of our development patterns. In general, we've just built too close to these very dynamic, highly variable, and hazard-prone shorelines, which is leaving our communities vulnerable, as well as damaging our important coastal environments and things like public access to these environments also. Studies of shoreline change in Hawaii, some of which I was involved in my graduate studies, show that about 70% of our beaches in Hawaii, that's Kauai, Oahu, and Maui, where most of our sandy beaches are chronically eroding. That means about 70% of our beaches, the shorelines are actually retreating back landward. It's as much as 80% on the island of Maui. With that erosion, we've experienced over 13 miles of beach loss, where we have beaches eroding or retreating in front of seawalls and coastal armoring. That'd be vertical seawall or rock revetment. We'll talk a little bit more about that in some slides coming up. But this has led to impacts to private property, that is the land, the public or private lands on the landward side of the beach that are getting eroded and actually losing property to the erosion. Impacts to public infrastructure like our coastal highways, which is a big problem on Maui, our east side of Oahu, Ka'ava, Punaluu. You may have seen some of the wave overwash and erosion along the highway there. It's been in the news recently. It also impacts coastal access, access to recreation. Beaches and shoreline environments are a big part of our culture, society here in Hawaii. Beaches are also important coastal ecosystems. They're haul-out points for monk seal, sea turtles, so that's an important impact that we're seeing more and more of. And then beaches are also critical to our visitor economy. So one of the ways we know about these dramatic changes going on shoreline is just from walking the beach and seeing this erosion and getting calls from coastal landowners and working closely with state government. And somebody has a home, we often get calls to go out to talk with homeowners that's that are being impacted by erosion. But we also have done a number of studies looking at how our shorelines have changed over the last century, looking back decades. And this is an example of a couple of studies. The one on the left is a series of maps that were developed for the counties of Kauai, Oahu, and Maui by the coastal geology group here at Hawaii, and I was involved in some of these mapping efforts. Show an example of one of the maps on the left from Sunset Beach here on the north shore of Oahu that shows the shoreline change trends that this beach has experienced over the last century. And historical shoreline positions are mapped from old aerial photographs and maps going back into the early 1900s. And then we measure the changes in those shoreline positions over time and can develop a rate of historical shoreline change. And that's what those bars along the coastline in that left-hand map show. The red bars being areas where the coastline is eroding or retreating landward, and the blue being areas that are roughly stable or actually accreting a little bit, that is growing landward. So there's a lot of variability along shore in how our beaches are changing, but overall, there's a net trend of beach erosion or beach retreat on about 70% of our beaches here in Hawaii. This information has been compiled in studies and peer-reviewed publications. This is an example of one of the government reports. This information was compiled in for the U.S. Geological Survey, the National Assessment of Shoreline Change, historical shoreline changes in the Hawaiian Islands. Both of these reports are available online. I particularly recommend the USGS report. It's got a really nice kind of summary primer at the beginning about coastal processes and how our beaches behave and the things that are driving the different changes on our beaches. If you're interested in reading more on that, the links are available there at the bottom. I mentioned the effects of coastal armoring on our beaches. This has led to widespread beach loss in Hawaii. About 13 miles of our beaches in all have been lost to erosion in front of seawalls or revetments like the one you see there on the left. Seawalls are generally effective at stabilizing the land from further erosion, but they can have serious impacts on our beaches as well as the neighboring properties. So you can see this small stretch of shoreline, this example where the beach has been lost in front of this rock structure, preserving the land behind it and the property behind it. But the beach that was there formerly has been lost in front of there. There's also things we call flanking erosion, these kind of end effects processes where the erosion is actually increased or accelerated on directly adjacent to these structures. It tends to increase the waves wrapping around there, the effects of those, and the current effects. The erosion tends to accelerate immediately next to these structures. But you can see that even though the erosion has increased on the side of the unprotected side of this structure, there still is a beach able to be sustained there. So as the shoreline retreats back, it's eroding sand out of the coastal plain behind it. And though it's retreating, a beach is still maintained there for public use. Coastal erosion is not the only hazard we face on our coastlines with climate change and sea level rise. We're seeing increased water levels with our high tides. And here's some examples of king tide flooding that we experienced in Honolulu in 2017. This received a lot of press around Hawaii. These pictures come from a database of photos that we maintain here at Hawaii Sea Grant, a program we run called the Hawaii Pacific King Tides Program, where we ask people to go out and shoot photos of high tide impacts. And you can see on the left some of the extreme high tide flooding at Mapunapuna. I'll show some more examples of that here in urban Honolulu, coming up through storm drain along the Alawai Canal, wave overwash flooding with extreme high tides, Waikiki, that's the Fort DeRussy area in the bottom left, and then wave overwash with the really high tides at Ala Moana Beach Park. These kind of flooding events are occurring more and more. This is from 2017. We had a similar event again in 2019, and these are caused by a combination of our highest tides of the year. Again, we refer to these generally as king tides. These are just caused by the moon and sun alignment and just our annual highest tides of the year. But when you add long-term sea level rise and shorter-term anomalies of elevated sea level that are just part of our natural variability, we start to see these kind of extreme tide events occurring. Where it used to be just once a year or twice a year, now these things are occurring multiple times a year as we have these added water levels on top of our astronomical king tides. And These photos from the king tide events kind of provide a glimpse at our future, where we expect these extreme tides to become more of our normal high tide events, with ongoing long-term sea level rise over the next few decades. So I mentioned that the vast majority of our beaches, 70% or more of our beaches, are chronically eroding. Coastal flooding is increasing. We expect these impacts to only get worse in coming decades, unfortunately, with climate change and sea level rise. And so local government agencies and resource managers in Hawaii are beginning to ask questions, have been asking questions for some time. They see these problems already happening, trying to deal with them on a day-to-day basis. How severe will this get in the future with climate change and sea level rise? And we're getting a better sense of that. I'll show some of the observations and planning we're doing. And then really where the conversation is shifting, what's really become more important at this point is what can we begin to do about these problems looking ahead for coming generations. So I want to shift gears a little bit and talk about some of the observations of climate change and sea level rise, and then we'll get into, following that, some of the projections for the future. In this figure, we're looking at the carbon dioxide concentration in the Earth's atmosphere, looking back over the last 800,000 years. So this is a long-term record of CO2 concentration in the Earth's atmosphere. This comes from gas bubbles trapped in ice cores. So scientists, researchers will go and core these long, deep ice cores from very old, very thick ice in Greenland and Antarctica, and they can actually extract gas bubbles from these ice cores and analyze the gas amounts in the atmosphere from that time when that snow was dropped and packed down into ice and became part of these deep ice sheets on the Greenland and Antarctic continents. And what we see is that the CO2 concentration in the atmosphere is quite variable. Looking again back over the last 800,000 years ago, what you see, these wiggles up and down happening over scales of tens or hundreds of thousand years, are the coming and going of ice ages up to the present on the right-hand side of the figure. The key takeaway for this that I want you to recognize is that we've now gone well outside the envelope of natural variability of CO2. Typically, the highest CO2 levels during interglacial periods. This is when the glaciers are generally away, like the warm periods like we're in right now, we're below 300 parts per million. We've now moved well outside of that natural envelope and are presently at about 413 parts per million of CO2. And so we're doing really kind of a dangerous experiment on the climate system. We have some understanding of what this can mean for the climate system. If we look at the last interglacial period, that was 120,000 years ago. That was the last period that you see in this plot when CO2 levels were relatively high. Temperatures at that time were as much as 2 degrees centigrade higher. The effects of that were that sea levels were 6 to 9 meters or 20 to 30 feet higher than present. So that time period, 120,000 years ago, the last interglacial period, is often used as an analog for where we may be heading with climate change and sea level rise in the coming decades and centuries. So we're adding all this carbon dioxide to the atmosphere. It's an important heat trapping gas. Without it, the Earth would be a snowball. With too much of it, things get too warm, and that's where we're headed. The plot on the upper left shows the CO2 concentration again, but over a much shorter time span. That's the black line looking back to just before 1900. That's plotted over the average global temperature record. Those blue, yellow, and red bars you see are the average annual temperature of Earth's surface atmosphere. And what you can see, and that's plotted relative to an average from the mid-century. So what you can see is that overall, global temperature has risen about 1 degree Celsius, or about 1.8 degrees Fahrenheit, since the late 19th century. And those red bars show record hot years from the time frame. And This slide is a little bit out of date, but we keep adding new records to the time frame, unfortunately. And I can tell you that 18 of the hottest years on record have occurred within the last 19 years. The one exception being 1998, which was an extreme El Nino event when we had increasing ocean temperatures temporarily from El Nino. So we keep breaking records, and we can expect that over the coming years as we continue along. It's interesting to note in the bottom right that the warming is not even over the planet. The reds and yellows and blues, the reds being the greatest degree of relative warming for that area. And you can see the warming is particularly concentrated in the northern parts of the northern hemisphere. And that is because there's just more land area in the northern hemisphere. That land area is heating up more. It's also concentrated in the northern part of the northern hemisphere because there's greater swings in temperature in the polar regions. And we're just not seeing the low temperatures we'd see, and we're seeing high temperatures. So there's more range, more ability for temperatures to change in the northern hemisphere. But we are seeing global warming, and it's a little bit more moderated around the oceans because the oceans do have a moderating effect overall on the global temperature. But those oceans are warming also, and we know that the oceans have absorbed about 90% of the heat energy added to the atmosphere, the global atmospheric system, since the 1960s. So without the oceans, the surface atmosphere heating would be much worse with the energy we're adding to the atmosphere with this increased CO2 concentration. The oceans have warmed about 0.4 degrees Fahrenheit since the 1960s, which is dangerous warming as well when averaged across the global oceans. You can see the warming is more concentrated in certain areas because of the global currents and everything that are moving around the global oceans and redistributing that heat in different ways. So with this warming, we're seeing rising sea levels, which I mentioned a number of times, where my work is really focused. This is a plot of global mean sea level from tide gauges around the planet. That's the portion of the plot in blue there, the blue wiggles you see going back to 1900. And then the red part of the graph there of the plot is from more recent satellite measurements of sea level, using a satellite that goes around, uses radar altimetry to measure changes in the global sea level. And what we see is this overall trend of rising sea level over the century, from about 0.5 millimeter per year in the early part of the century, doubling up to the middle part of the century, and doubling or more again up to recent decades, where we're now at about 3.2 millimeters of sea level rise per year. If you extrapolate that out over a century, that's about 13 inches per century. So if you were to extend that line linearly out into the next century, that's the minimum of what we could expect, about a foot of sea level rise over this century, the rest of the century. But we're seeing this acceleration in the global mean record. And so if this acceleration that we observe continues, the minimum sea level rise we expect is about 2 feet of sea level. So that's really kind of the minimum sea level we expect over the coming century, is about 2 feet of sea level rise with this ongoing acceleration. We can also see the sea level rise in local tide gauges around Hawaii. This is the tide gauge plot from Honolulu Harbor. Though historically rates of sea level rise around Hawaii have been somewhat lower than the global mean, this is due to natural variability. We don't expect this to continue. Hawaii will begin to catch up soon with the global record and probably overtake that in the coming decades if it hasn't already. The acceleration may be in there and may just not be statistically discernible at this time, just due to that natural variability in the records from individual tide gauges. You can see that variability in the wiggles and the blue lines. That's the monthly mean sea level, and then a long-term trend of sea level rise, that line that's fitted to that long-term data set, the blue line of sea level trends in Honolulu. So what is causing our oceans to rise? Well, it's this warming, but it's 2 major factors. The first is meltwater from glaciers and polar ice sheets. And then second component is thermal expansion. As you warm up water, the water actually expands somewhat like a gas, so the effect is not as much as a gas. So as we're warming the upper and mid levels of the oceans, the water column is actually expanding and rising with that. Thermal expansion was roughly equal to the added water component in past decades, but now you can see from the plot on the left-hand side, the added water component is now overtaking and about double what the thermal expansion component was. And if you add that up, it fits quite well with the overall global sea level trend that you see the black line there in that plot. So mountain glaciers and the cryosphere and the ice systems around the planet are experiencing dramatic changes. And this is an example of one of the glaciers that's experienced dramatic retreat. This is the Mendenhall Glacier in Juneau, Alaska. And I had the opportunity to visit this glacier a year ago. This is my first time visiting a glacier. It's a spectacular site, beautiful place. But it was really shocking when our tour guide showing us photos and describing the changes they've observed in this area, in this national park, since the late 1800s. This bay was formerly completely filled with the tongue of the glacier coming well out into there. And then you see a similar picture from recent that shows completely open water. The glacier is retreated all the way back into the hills, leaving this large lake, which is formed in the last few decades. So this is just one example of the kind of dramatic changes that we're seeing in glaciers around the planet. Of even more concern are these changes that we're seeing on Earth's major ice sheets. And this is a map of the ice loss that Greenland has experienced over the last few decades, going back to 2002, measured from a satellite that measures the gravity of the ice sheet and was able to back out the changes in mass as a result from melting across the Greenland ice sheet. What you see here, the red areas indicate the areas of the most ice mass loss on Greenland. The line between the yellow and the white areas is called the equilibrium line. And we not only see this ice mass loss in these areas, but we also see this equilibrium line that is slowly creeping uphill to the higher elevations of the white part of the ice sheet there. So we do forecast a period likely in the next few decades where the entirety of the Greenland ice sheet will be in a stage of overall melting. And from that satellite, able to back out measurements of the total ice mass loss. And overall, I find that Greenland is losing about 281 gigatons, that's billion tons a year of ice is being lost from this continental ice sheet as meltwater to the ocean. So that's a major contribution, growing contribution to sea level rise. We have a similar data set from Antarctica, major ice sheet there. From the GRACE satellite. We also find that Antarctica is overall losing ice mass, but the story is a little more complicated than Greenland. Antarctica is losing about half the rate of Greenland at this point overall. The ice loss, is mostly concentrated in the West Antarctica portion of the continent, on the left side of the continent, those red areas, where a number of accelerating outlet glaciers have been identified. Perhaps most concerning, we see this net trend of ice loss in the plot on the left. If you were to fit a line to that, it would actually be a downward sloping curve. So the ice loss appears to be accelerating on Antarctica. So those were observations. We're going to shift gears a little bit and talk about forecasts, predictions for the future, next few decades out to the century. Where are we headed in the future? It gets a little trickier when we try to project these trends out in the future because there's a range of possible greenhouse gas emission scenarios, and our understanding of polar ice behavior to warming continues to improve. What you see here is a recent report from the National Oceanic and Atmospheric Administration from 2017, and this is one of the key plots below that from that report, showing a range of potential global mean sea level rise scenarios looking out toward 2100. This plot goes from 1800, shows the observed sea level trend in black, and then into that kind of purplish color up to the present, and then these projections out in the future. And you can see there's quite a range of projections looking out to 2100. It goes from that dark blue line, which would be a linear projection of the current global mean sea level rate, which I told you we're already seeing acceleration, so we don't expect that. The blue line, the kind of medium blue line, is a projection looking at the current acceleration, so that's kind of a medium low, and then a range of other scenarios from medium, intermediate to high of projections based on the latest peer-reviewed science. That was kind of the approach for this report, was to look at the range of all the science and look at a range of potential scenarios. In particular, the state of Hawaii, and I'll get into some of the planning that we're doing with the state, is kind of focused in on this intermediate scenario. That's that kind of turquoise light blue scenario that points to about a meter sea level rise, or about 3.2 feet of sea level. But in reality, so those plots kind of show these smooth curves of sea level rise. In reality, when we look at individual location, say an individual tide gauge, like our Honolulu tide gauge, sea level does not really follow these smooth curves. There's natural variability on top of the long-term global mean sea level at the local scale. And that's what this figure is meant to show. So as a result, we'll expect to see these extreme tidal flooding events decades before those heights of global mean sea level are reached. So that black curve is kind of meant to depict that long-term kind of smoother curve that comes from projections like NOAA. But in reality, we're going to have these wiggles. And we're going to see these extreme tidal events happening more frequently and more severely that we're experiencing now, but these are going to come more and more in the coming decades before that actual global mean sea level rate is reached. Now, briefly, I just want to mention that sea level rise is not the only impact we expect from climate change and are experiencing from climate change. We're also seeing and will see more intense heat waves, which is a risk to human health, impact to electrical grid and transportation infrastructure. People are going to need more air conditioning to stay cool and be safe, and that's going to require more power. Water supply impacts, we're seeing changes in rainfall, groundwater, stream flow, so that can affect water supply in some areas. The oceans are warming. They're also taking up much of the CO2 that's being put into the atmosphere, so we're seeing more coral reef bleaching and loss to our coral reef environments, which is impacts to loss of critical habitat for rare species and crucial species here in Hawaii, and can affect things like our fisheries and ocean biodiversity. So what are we going to do about this? So I want to shift a little bit here. We talked about observations, we talked about projections. Now we're going to get into how do we address this. And I think this is the most important discussion, really where we're at right now in talking about this here in Hawaii and at a national and a global scale, is how are we going to address this climate change and these impacts? Well, it requires kind of a two-pronged approach. The first is adaptation, and this is adjustments in response to actual or expected climatic or environmental impacts. That is, what are we going to do to address the sea level rise that we expect to face here in the coming century or coming decades? And the other side of it is the mitigation. The other crucial part of it is interventions to reduce the human-induced causes of climate warming, and that's primarily reducing greenhouse gas emissions, but it's also things like looking at land use, not cutting down forests in the Amazon and elsewhere. So it's two major approaches. Sea level rise, I've talked a lot about that. That's really where this talk is focused, where my work is focused. And a lot of that's on the adaptation, dealing with those impacts. But sea level rise also serves as one of the major factors, serving as a major wake-up call that we really have to make dramatic reductions to our greenhouse gas emissions. So I want to spend the rest of the talk then talking about and describing some of the work that our government, our researchers, and our communities are beginning to do to address these challenges. Some of the work that I'm involved in through my partnerships, through Sea Grant and local government. Hawaii, the state of Hawaii passed 2 landmark pieces of legislation, bills. You can see the governor and some of our state legislators in 2017 when they signed the Hawaii Climate Change Mitigation and Adaptation Initiative. With that initiative, Hawaii became the first state to enact legislation that implements portions of the Paris Climate Agreement. It also established a Hawaii Climate Change Mitigation and Adaptation Commission, which meets regularly, is made up of legislators of key committees and heads of key relevant state and county agencies. This commission's intended to provide policy direction, coordination, and planning among those agencies, as well as establish climate change mitigation and adaptation strategies. The Act also directed the development of a statewide sea level rise vulnerability and adaptation report. That report was completed and accepted by the State Climate Commission at the end of 2017. This is an effort I was deeply involved in through my work with the state of Hawaii, and particularly the Department of Land and Natural Resources. Provide an overall assessment of potential impacts of sea level rise to our state. Did some detailed modeling, working really closely with the Hawaii School of Ocean, Earth Science, and Technology, particularly the coastal geology group there, to map sea level rise impacts. And we also developed an online mapping tool that you see there on the right, the Hawaii Sea Level Rise Viewer. This is available online as well at hawaiisealevelriseviewer.org. And it allows you to zoom in, look at, play with the mapped sea level rise vulnerability data that was developed for the State Sea Level Rise Report. You can think of it as an online atlas. And these tools have proven really critical to helping agencies and decision makers in Hawaii to really begin to interpret what sea level rise looks like for our not too distant future, and beginning to take some critical steps towards planning and policy. And I'll talk some more about those planning and policy approaches a little bit. I want to talk first about the modeling, the results of this report, and the science behind it. So with the Hawaii Sea Level Rise Report and Viewer, we modeled 3 types of flooding impacts with sea level rise. The report focuses in particularly on a scenario of 3 feet of sea level rise, which is roughly equivalent to that intermediate scenario that I showed you from the NOAA report. Somewhere out towards 2100 in a more intermediate scenario, possibly as soon as 2060 if the more extreme scenarios become realized. And that's, again, an area of evolving science. But among researchers and government entities, really have kind of settled on this 3-foot scenario as the key planning target for development and infrastructure within the century. And that's consistent with some guidance that also came out from the Honolulu City Climate Commission, focused in on particularly 3 feet of sea level rise for most development, but as much as 6 feet of sea level rise in the century for critical infrastructure. So what we're looking at here is the first model that was done, the first mapping that was done for sea level rise. This is often referred to as kind of a bathtub model or passive flooding. This is simply raising a mean high tide level with additional sea level. Right now we're looking at mean high tide plus 3 feet. So it just shows areas that would be below high tide at that level in blue here. Showing 3 feet, but this is also modeled and available in the Sea Level Rise Viewer at 1/2 foot, 1 foot, 2 feet. And you can see that on the clickable legend on the right-hand side of the viewer in this figure. And again, we're already starting to see these impacts. We're looking at an area of downtown Honolulu. This is Mapunapuna. And this is some of the high tide flooding in the picture that we're experiencing there now with our extreme tides. So this is not something far off in the distance in the future. These are impacts that we're seeing increasingly now. The second impact that was modeled for the State Sea Level Rise Report map was wave run-up. This takes an annual high wave event from offshore buoy data, adds sea level rise to that annual high wave event, and uses a program modeling to run that high wave event up over the shoreline. And what you see in blue in this area, areas that would be flooded from your typical annual high wave event with 3 feet of sea level rise. This is a section of West Maui, the highway, Hanoa Pi'ilani Highway, going from Ma'alaya out to Lahaina. And some of the flooding that we're already experiencing along this highway with increasing sea level and high wave events on an annual basis, actually more frequently on this highway, and you can see the waves running up over the highway there. The third thing that was modeled for the report was coastal erosion. And we have that data set of historical erosion, shoreline trends that I showed you earlier in the talk. That's part of this model. There's also a model that's used to project how beaches behave with sea level rise. Those are combined into kind of a hybrid modeling approach. And what we're seeing here is a section of Sunset Beach on the north shore of Oahu. The green line is the current back of the beach or vegetation line. The yellow line, based on historical trend and the other model, shows where the shoreline potentially could be with 1 foot of sea level rise. And then the red line shows where the shoreline could potentially be with 3 feet of sea level rise. This is an erosion hazard area based on those historical and modeled trends of shoreline change. And as many of you may have seen in the news or seen in person, we are experiencing erosion throughout this area of Sunset Beach. Just one example of kind of erosion we're seeing in Hawaii. This section of the bike path in front of Sunset Beach Park was completely lost to erosion about a year or two ago. Has since been retreated back, and those palm trees have been removed. So types of impacts we expect to see more and more in this area and statewide. So those 3 impacts, the passive flooding, the annual high wave flooding, and the coastal erosion, were combined into an overall sea level rise exposure area for the report. Regardless of which hazard, these areas are prone to chronic or repeat flooding and land loss at a particular sea level height. Again, these maps of the sea level rise exposure area, or SLREXA, SLRXA, it's often referred to, SLREXA, that horrible acronym. This is an example of Waikiki showing 3.2 feet of sea level rise, showing that SLREXA for Waikiki. That map layer was also used to provide the basis for assessing potential impacts at the island to statewide scale, looking at economic impacts. And that's what you see on the right is the value in dollars of potential loss of buildings and land at that 3.2 foot scenario. Those red squares, these are this modeling, this economic assessment of loss of that sea level rise was done at the property level scale, but was kind of aggregated up to these 1 hectare grids that you see on the right. The dark red grids there over Waikiki, not surprising, are our highest values. Those would be $50 to $100 million in private property loss at that sea level rise scenario. But it is important to caveat this all is based on the assumption that there's no adaptation measure taken. It's based on present day dollars, present day development, and what would happen at that sea level rise flooding scenario. We totaled up those values statewide and found that 19 billion in loss of land and structures is possible with 3.2 feet of sea level rise. Untold $billions in overall infrastructure, public infrastructure needs more assessment, loss. So we don't have a good figure yet. That's kind of a critical gap that we need to address, is how much roads, other critical infrastructure, flooding, stormwater management are at risk with sea level rise. It's likely an order of magnitude greater than the estimated loss to private land and structures. But we do know that about 116 miles of road potentially flooded when we overlay the sea level rise exposure area on a road. 6,500 structures completely chronically flooded. As many as 20,000 people potentially displaced without any adaptation or mitigation measures with 3 feet of sea level rise. So sea level rise adaptation strategies are typically described by 4 general approaches. The first is to protect or harden. This would be seawalls, rock revetments, like you see in the top left pictures. This approach typically prioritizes protecting people and property typically employs shoreline armoring in structures like seawalls. The second approach is to accommodate, where you're staying in place, but and allowing continued development, but requiring buildings to be constructed or retrofitted for improved resilience. But with that, also limiting shoreline armoring. The third is retreat, or often referred to as planned realignment or managed retreat. This approach discourages development in hazard-prone areas, but also plans for relocation of existing development in the most hazard-prone areas to begin to move that development inland, and particularly in areas where we want to preserve beaches and other natural coastal ecosystems. And the fourth approach is to preserve, to make sure we are preserving and restoring our existing natural or lightly developed coastal environments for their ecosystem value and as a natural buffer to coastal hazards. There's not a one-size-fits-all approach to addressing sea level rise. It takes a whole spectrum of approaches like this, and approaching these things on a case-by-case, location-by-location specific approach. Protection, further hardening, for example, may be appropriate around our harbors as an easy example. But retreat and preserving our natural ecosystems are maybe the more ideal approach. We want to try to sustain our beaches for future generations and other coastal environments like wetlands. We may have to get out of the way in some of those areas if we want those environments to survive with sea level rise. I've talked a little bit about this, different sea level rise scenario planning for adaptation. It is difficult trying to make decision making under these conditions of uncertainty, this wide range of scenarios. The state and city of Honolulu and others, county governments, have kind of focused in on these two scenarios, particularly this 3-foot scenario for residential development. This is private development that has moderate lifespan, and maybe can really be more approached as adaptive design, things like elevating, retreating back on properties where we can. And then for major public infrastructure, we need to start considering more serious sea level rise scenarios, perhaps as high as 6 foot. And this would be for particularly long-lived, high investment, low risk tolerant development, things like a major new roadway or power plant. Really should start to consider higher sea level rise scenarios. And this is consistent, again, with what the guidance that came out from the City of Honolulu Climate Change Commission, which builds on the findings of the State Sea Level Rise Report and other recent science. So our government agencies at the state and county levels are beginning to get serious about climate change and sea level rise adaptation. I just want to point out some of the important steps forward that have been taken recently. The mayor of Honolulu and the Maui mayor a couple years ago released directives telling their county agencies to begin planning and addressing for climate change and sea level rise, particularly using the data from the State Sea Level Rise Report and the Sea Level Rise Viewer in their planning and permitting programs. And the City of Honolulu, a year ago now, released their overall island-wide Oahu resilience strategy. The picture on the top right is the event where the mayor released the new Honolulu resilience strategy, and you can see him showing our Hawaii Sea Level Rise Viewer on the image in the background. There was also an important piece of state legislation, State Act 17, a couple years ago, that now requires consideration of sea level rise in environmental assessments and environmental impact statements. So that's a key part in the planning and permitting process, where a project proponent or consultant or agency will have to do a full assessment, an EIS or EA, but now have to consider climate change and sea level rise aspects in doing that process. The state's hazard mitigation plan was also updated a year ago, and this includes much expanded consideration of sea level rise hazards, building off of the data that came from the State Sea Level Rise Report and Viewer. All right, some of the other work that I'm involved in and that we're doing here at Hawaii Sea Grant is developing guidance for disaster recovery preparedness in Hawaii. Sea level rise will not just impact our communities through kind of the slow creep of rising tides and rising wave overwash. We're also going to see increasing frequency and severity of impacts from things like hurricanes and extreme rainfall and extreme high wave events, whose impacts are compounded by additional sea level rise underneath them. But if we plan properly, if we plan ahead of time, we can use these disasters as opportunities to adapt and improve our resilience to future hazards. Sea Grant is working closely through this project with local government. We developed this guidance mid last year, and we provide a range of planning and policy recommendations to be taken, again, before a disaster strikes, to be better prepared for long-term recovery and rebuilding. And the activities, the guidance in this report are particularly focused on the planning and permitting process, as well as emergency management offices to better facilitate long-term planning, again, to improve our resilience to future disasters through the disaster recovery process. Another project we're doing in close partnership with county government and the county planning departments is developing this guidance for addressing sea level rise and community planning in Hawaii. This is an ongoing project. We're almost done with this guidance. You may or may not be aware of our counties, by state and county law, are each required to regularly update island scale and community scale development plans. They're called different things: community development plan, sustainable communities plans for some of our plans here on Oahu. But in general, these plans are intended to provide a vision for how we want to develop our communities looking decades ahead. And we really looked at this as a critical first step in addressing sea level rise. We can provide a climate change and sea level rise informed vision and plan for our communities through these required plan updates. We're near completion on the guidance, and we're working hand in hand with our counties on a number of efforts to update these newly available, or to update community plans based on this newly available sea level rise data. And on the right-hand side is one example of how that new sea level rise data is being integrated into plan updates. This is from the ongoing Honolulu Primary Urban Center Development Plan update. It's in draft form right now. There should be a public review draft available soon. What we did with this effort, this is a figure from that ongoing effort, some of the public outreach, is took the state sea level rise report data and viewer data and downscaled it to the PUC community plan area that's shown in this map. These kinds of downscaled vulnerability assessments are a key part of the community planning process and something we're seeing more and more of in Hawaii. So those are some examples of sea level rise planning in Hawaii, some of the critical key steps we are taking here in Hawaii. But I just want to touch briefly, coming towards the end here, on some of the key things we're doing on the other side of addressing climate change. Again, that's the greenhouse gas mitigation. And this figure comes from the state climate website, climate.hawaii.gov, and points out some of the key goals that we're aiming for and that have been adopted here in Hawaii. Particularly on the right-hand side, I want to point out that we have, as a state, has committed to 100% renewable power consumption by 2045, and along with that, a carbon neutral goal that is less emissions than offsets by 2045. So the other critical steps that we're taking towards addressing this climate change crisis. So last slide, I just want to talk a little bit about, where we are at this point, going through this pandemic, this COVID crisis. All this can feel especially overwhelming. I mean, the sea level rise and climate change stuff is tough enough on its own, but now we're facing this pandemic. It can feel pretty overwhelming, I'm sure. Hopefully I didn't depress too many people with this talk. I do my best to remain optimistic. I hope we all can. Really trust in the ingenuity and creativity of humankind to get through this climate crisis. That is to really malama aina, take care of our planet, live in a more sustainable manner. I really look to climate change not as an overwhelming burden challenge that we can't address, but as an opportunity to do what we should have been doing all along. And I think if anything, this COVID crisis this pandemic is still evolving, but I see some hope in this as well related to climate change. It's shown us that transformative change is possible on a global scale if we take these kind of threats, these global threats seriously. And it is possible for us to come together globally to address these global problems. So that's the end of my presentation. I'm sorry I'm not available live for question and answer and discussion, but feel free to reach out to me at my email address, Romine, R-O-M-I-N-E, @hawaii.edu. Be happy to answer any questions or get in touch with you for any further discussion. So that's what I have. Thanks for tuning in.